Alright, in this video we're going to talk about the Unit 4 Quiz 4. This is the thing that you guys took actually yesterday. So we're going to go through it just like we did on Monday. Now first off, a couple things. Arithmetic sequence, the buzzwords I'm looking for is adding. If I see adding anywhere, if I see that word, heck, sometimes it's next. Alright, next one is geometric sequence. If I ever see a percentage, I know it's always going to be geometric. If I ever see the letter R, I know it's going to be geometric. And if I ever see something like doubles, triple, that's all going to be geometric. All right. So these are the buzzwords in which you need to figure out, or which you need to find as you're going through each and every question. All right. So let's go ahead and get us started. First thing we're looking at is determining whether or not these sequences are arithmetic, geometric, quadratic, or cubic. Both or neither. Alright, we'll talk a little more about that in a second. First off, 28, 42, let's say 28 and 42, the difference between that is 14. The next one is 18. The next one is 22. The next one is 26. And lastly, the next one here is 30. Now, notice they're not the same. So I already know it's not going to be arithmetic. Alright, next is going to be the next level, which is 4, 4, 4, 4. I went down to my second level. Remember that this right here, that's level 1. This is level 2. Alright, so I went down to my second level. Alright, so my second level, that is always going to be quadratic. Alright, so that is quadratic. Now, I'm going to skip that one for a second, move to this one here. Alright, negative 110, negative 128, negative 146. Alright, so negative 110, negative 128, that is a difference of 18. This right here 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 is a difference of 18. So they're all the same, which means it is going to be arithmetic. Alright. This one right here, 69, 130, 221. Well, let's go ahead and start finding the differences. 61, 91, 127, 169, 217, 30, 36, 42, 48. Keep going, 6, 6, 6. All right, so that's going down to my third level here. So again, if you need to visually see it, level 1, level 2, level 3. So this is my third level. Anything that's a third level is always going to be cubic. Alright, now, this guy right here. Most of you guys put neither. Alright, now, the reason why you put neither is because you started doing the differences, and when you started doing the differences, you notice that you never got to that certain point. Alright, so you never got to that certain point, and so, which means your first level, you did not have the same numbers. Your second level, you didn't have the same numbers. Your third level didn't have the same numbers. Didn't even have the same going all the way down. So you're thinking, oh, it's got to be neither. Now, this was kind of a tricky one because remember, geometric is when you're multiplying. Observe what all of the numbers are doing. 12 to 24, I'm timesing it by 2. 24 to 48, I'm timesing it by 2. 48 to 96, timesing it by 2. So on and so forth, so on and so forth. So what's happening is I'm multiplying by 2 every single time. So the answer is geometric. Alright? Now, some people got it right because they were just doing process elimination. This was quadratic, this was geometric, this was arithmetic. So this one was cubic and they didn't do the work. So if that is you, don't fall in love with that next time. Alright? Alright. Here we go. George raises rabbits for meat. Unfortunately, there's an illness infected rabbits in their population. Alright, so here we go. 13%. Alright, let me see if I can get a little closer here. Alright. I don't know if that helped or hurt. Alright, so 13%. Because of the fact that that's a percent, I automatically know, let me go back to my formulas, it's going to be geometric. Alright, so this is what you need to do. Before you do anything, write down your geometric sequence. So that means A of n is equal to something, parentheses something, n minus 1. The reason you do that first is because you know that you have to find your first term, you got to find your R. All right, so don't do anything until you write this down first. This is a visual. This keeps you straight with your information. All right, so you are decreasing by 13%. Remember that with that, you are going to subtract this from 100. You get 87%, which means it's going to be 0.87. So I have 0.87 as my R. So let's go ahead and solve it. 0.87. The next information I have is by month 13, he had 56 rabbits left. So that means A of 13 equals 56. All right? Remember, 56 goes there, 13 goes there. So 56 is equal to X. Remember, I don't know what my first term is. Got to put an X there. X parenthesis 0.87 raised to the 13 minus 1 power. Okay? So when I do that, I'm going to get 56 is equal to X. Now, depending on how you round it is your next, your step here. I think it was 0.188. Let me check that just to be on the safe side. Yep, I'm good. Now, here's what some of you guys are doing. I'm going to write it over here. 56 plus 0.188. So my step above it was 56 equal to X times 0.87 times 13 minus 1. How the heck did that multiplication problem become an addition problem? Where did that addition sign come from? Alright, some of you guys are making that mistake. Do not make that mistake. It's a multiplication problem. Keep it a multiplication problem. Divide that by 0.188. And so when you do that, you get an answer of, I'm rounding, 298. Now, you might have gotten a different answer depending on how you rounded. If I didn't mark you wrong, you're correct. So don't freak out on that. Now, going back to my original sequence, and that is A of n is equal to something, parentheses something, to the n minus 1 power. All right, this first something is my first term, 298. 0.87 is my R. That's it. All right, so 298, parentheses, 0.87 to the n minus 1 power. Okay, now next is write a recursive rule for the problem. Recursive rule, let me go back, is A, well that's T of n, but that's A of n minus 1, whatever you're doing. What you are adding, subtracting, or multiplying. Alright, so A n minus 1 times, if you want to put times there, that's fine, 0.87. What a lot of you guys are doing is A n minus 1 plus 0.87. Guys, you're not adding 0.87, you're multiplying it. Alright, it's geometric. Stay in there. Lastly, if the illness was never cured, how many months will until 10 rabbits left? Alright, this is our guess and check. And I got a nice calculator so you can see this. So, what's that? 298. 298 times 0.87 raised to the power of, I'm guessing, 10 minus 1. On my 10th year, I have 85 rabbits left. Alright, obviously, that is too big. That is too small. So let's keep going. 298 times 0.87 raised to the power of 15 minus 1. 42. I'm getting closer. Good. 298 times 0.87. Let's just say raised to the power of 20 minus 1. Oh, I'm at 21. I'm getting closer. All right, 298 times 0.87 raised to the power of, let's just say 22 minus 1. Look at that, 16, getting even closer. 298 times 0.87 raised to the power of, let's just say 24 minus 1. Closer. 298 times 0.87 raised to the power of 25 minus 1. There we go. On my 25th year, I'm at 10.5. So that means 298 times 0.87 raised to the power of 26 minus 1. There we are. Between 25 and 26 years. 25 to 26 months, I'm sorry. There you go. So notice what I did here. I basically just plugged and chugged until I found 10 and 9. All right. Next question. Most of you guys got this right, so y'all might be skipping over this part. Now, a small college auditorium has 30 seats in the front row, each successive row, moving backward. Here we go. Buzzword, additional. That means it's going to be arithmetic. So before I do anything, I'm going to write down my arithmetic sequence. Something plus something, n minus 1. This is my first term. This is my, common difference, D. Almost put an R there. All right, now let's keep reading. 30 seats in the front row. That's A of 1 is 30. Okay, 2 additional seats every single time. Common difference of 2. All right, now is this problem arithmetic or geometric? It's arithmetic. Notice it's arithmetic. Everything is arithmetic in this. Okay, some of you guys are saying arithmetic and then you're doing geometric stuff. Don't do that. This question has a common, well, it's a difference because it's arithmetic, so that's common difference, and it is 2 because I'm adding 2 every single time. Write a closed form rule for the problem. All right. Well, going back up here, my first term is 30. Common difference is 2. Simplify. Some of you guys are not simplifying. 30 plus 2n minus 2. Combining those things, you get 28 plus 2n. 28 plus 2n. There we go. Now lastly, if the last row had 90 seats, how many rows would the auditorium have? This is a guess and check situation. All right. Now, some of you guys are getting confused about, okay, do I take 90 and throw it into n, or do I guess and check? Here's the safe rule that I always like to do, and that is, if this number is small, usually that means plug into n. But if that number is large, usually that's going to be a guess and check situation. So 90 is relatively large, so I'm going to guess and check. So basically off to the side here. Now, because this is arithmetic, you can actually set this equal to this if you really wanted to. So 90 is equal to 28 plus 2n. Subtract 28, subtract 28. I believe that 72 is equal to 2n. Nope, how about we say 62? 62, n is equal to 31. N is equal to 31, so how many seats? 31. All right? So again, this little tidbit here that I wrote here, this works most of the time, not every single time. But most of the time, if you're like, okay, I don't know if to plug it into n or guess and check. If it's a small number, most likely you're plugging it into n. If it's a large number, you're most likely guessing and checking. That's pretty much the rule of thumb. It's not all the time, but it's most of the time. All right. John's dad has a job for him to do. The way the job is set up, John will get paid more to start the job, which is the first hour, and then get paid normally hourly rate. All right. Now, I see that this might confuse people because the word rate is in there. All right, so before we start dealing with the geometric, let's kind of make sure. Let's see, going down here. Oh, look, there's a common difference right there. So I know because of the fact that there's a D there, it's going to be arithmetic. Because notice, going back to my formula, there it is. All right, so A of n is equal to something plus something n minus 1. Remember, this is my first term. This is my common difference. After 3 hours of work, A of 3 is 55. After 6 hour work, A of 6 is 100. We got to find our common difference. Now, look what I did. I gave you how to find your common difference. Subtract the later term by the earlier term. So the later term is 100. So 100 minus 55. And then I'm going to divide by, let's see, the number of jumps. Well, 3 and 6. That's 3. So I get a common difference of 15, I believe. Yep. So the common difference of 15. But again, because of the fact that I wrote this out to begin with, I know that my next step has got to be finding our first term. So I'm going to choose between 55 and 100. 55. And it's little brother 3. I got to take that. So 55 will go here. 3 will go here. So off to the side here. 55 is equal to x plus 15 times 3 minus 1. Do the math. 55 is equal to x plus 30. I can't tell you how many people do this. Don't do this, but I'm showing it to you. They go 55 is equal to 30x. So all of a sudden this addition problem, which clearly is an addition problem, has now gone to a multiplication problem. Don't make that mistake. Subtract 30, subtract 30, x is equal to 25. This is my first term. So how much did John make an hour? 15 bucks. But his first hour he made 25 bucks. Write a closed form rule. All right, closed form rules. A of n is equal to something plus something n minus 1. Common difference goes here. His first term goes there. 15n minus 15. I don't know why I wrote it like that, but I did. Minus 15 that. 10 plus 15n. All right. Write a recursive. What am I doing every single time? I am adding 15 because that's what my common difference is. So an minus 1 plus 15. Plus 15. Not times 15. So you guys aren't putting the plus there. How much money will John have after 40 hours? Okay. Now 40 hours, this goes back to this whole concept of if it's a small number, put it into n. If it's a large number, guess and check. All right. So 40 is roughly small. Okay. So I'm going to take 40. I'm going to plug it in for n. All right. So that means 40. Plug it in for n. So that will be off to the side. 10 plus 15 times 40. Do the math, and I get 610. All right. Now, if you're still having trouble going back to the whole, well, do I plug it in for n or guess and check? Be sure to see me, all right, and we'll work on it a little more.